So after those two very interesting presentations about AI in healthcare, we go a little bit deeper the stack, the technology stack, talking about cloud. Because cloud is very important for innovation and for the architectural basis for all the innovations we talk about. And we will hear a speech, a keynote speech, and I'm very honored in this context to introduce Phil Venables, who's the global CISO of Google Cloud. In this context, he's responsible for risk, security, compliance, and privacy teams at Google Cloud, and he's talking about cloud security megatrends, no data-driven innovation without security. Phil, the stage is yours.
Thank you. And thank you for having us here. So we're often asked the question, is cloud more secure than on-premise environments, traditional data center on-premise environments? And it won't come as a surprise, given my job, that the answer to that is absolutely yes, right? But in reality, the answer is a lot more nuanced in the sense that there are plenty of traditional large enterprises that can and do spend a lot of money to invest on creating on-premise high degrees of security. It's quite unusual because it does take a lot of effort to do that on-premise. And then similarly, there's plenty of customer issues in cloud misconfigurations that cause exposed storage buckets or other incidents. But generally speaking, what we're finding is more and more the default level of security in the cloud and what customers of all sizes can achieve in the cloud is generally surpassing quite easily what is available and traditionally able to be constructed in on-premise. And there's a few reasons for this. It's not just because companies like us are investing a lot in security, although we are. We've committed another $10 billion to spend on cybersecurity technology in the next few years alone. And it's not just because we have large numbers of world-class security engineers, although we do, but really the real reason is there's a set of drivers, what we call megatrends, which are these unstoppable forces that almost drive to the point that you can't help that hyperscale cloud gets more and more secure. So what I'm going to do is I'm just going to very quickly step through. There are 8 trends I'm going to go through very quickly and just give you this background about why we think this has become more and more compelling, that cloud becomes more secure over time. And when I talk about this, I'm really thinking about all hyperscale cloud providers. But of course, I'm about to say that of all the hyperscale cloud providers, we're doing this more than everybody else. So, the first one is economy of scale. So the scale of our environment is such now that we can invest in high levels of security and control, that we can amortize or apportion the cost across this big fleet of infrastructure that we have. So hyperscale cloud ultimately becomes this epitome of raising the baseline of control because we're reducing the unit cost of control. I'll give you an example on this. So a few years ago, we developed a security chip. It's called the Titan security chip. It's in all of our servers. It acts as a cryptographic root of trust, and it acts as a means of doing firmware validation. This cost us a lot of money to design and develop that silicon and ship that silicon. But now the cost of that across millions of servers is just pennies. And we do this a lot. For example, an example of commoditizing that. So at the time, we also had a product called shielded VMs, which is virtual machines tied to that trusted platform module. We don't have those anymore because all VMs are shielded VMs. We've commoditized that control, so that high level of security is just available. And so this economy of scale is going to keep driving up this default level of security. And interestingly, as on-premise environments shrink over time, this trend is working in the opposite direction, that their unit cost of control is going up, making cloud an even more attractive proposition. The second thing is something we call shared fate. So you've all heard the shared responsibility model, where the cloud provider runs the base infrastructure and the customer's responsible for configuration. We've started driving this notion, and I think all cloud providers are going to end up in this place, where we talk about shared fate, which is if a customer has a security issue because of their misconfiguration, we, the cloud provider, should feel in some respects responsible for that, in the sense that Could we have shipped a better product, better defaults, better blueprints, better configuration advice? And increasingly what happens is all the cloud providers, when they see customer pain on security or issues, are responding by making the products more secure by default, easier to secure. And this cycle of shared fate, again, keeps increasing customers' security. And ultimately, and this is a unique thing for us, but I think the other cloud providers are going there, we also provide discounted cybersecurity insurance. We do this in partnership with Allianz and Munich Re, where we backstop a lot of the capability to enable customers to get discounted insurance on the platform. That's the ultimate expression of shared fate. The third thing is healthy competition. So again, many of you have probably kind of observed this, is all of the big cloud providers, we are in ruthless competition with each other for business. And in winning customer business, the requirement number one, or at least number two, but mostly number one, is security. So some of you may have kind of had careers that have spanned working in on-premise enterprise software, traditional enterprise hardware environments. There's never really been this dynamic before where there's been such immense competition with companies with a lot of resources to spend driving security up as a competitive edge. In many respects, in some of my old enterprise CISO roles, I would talk to enterprise software companies and say, I really need you to do more security. And the enterprise software company would go, you're the only customer that's asking for this. You know, we're going to have to charge you for it. And you would think, well, it's kind of BS. We know everybody's asking for more security. But there was no dynamic in the marketplace that drove up security. Now, I think, for the first time, we've got massive tech companies competing ruthlessly to drive up security, and that's something that benefits everybody. The fourth one is we start to see cloud as a digital immune system. So what do I mean by this? So every month we ship hundreds of security updates. These are new features, new control features, new security products, new security elements embedded in other products. It could be fixes to vulnerabilities that we've seen through threat and vulnerability research. It could be things coming out of our bug bounty programs. But generally speaking, what happens is every month there's hundreds of new security features that are being shipped. Now, the great thing for most companies that don't necessarily have large security teams, one of your best security strategies is just to sit back and take every update the large cloud providers provide, and it's like a rising tide lifting all boats. And again, the reason I kind of think of it as a digital immune system is sometimes there'll be a feature we ship that closes off a vulnerability that may have been discovered by some particular emerging new sophisticated threat, that it would have taken 6 to 12 months for your organization to see that attack, but we're able to respond to that quickly, like an immune system, build that control across the platform, and protect organizations before the threats actually come to their particular organization. And the fact that we're working this faster and faster and faster means that we're going to be more responsive. And again, that's another dynamic. There's no means of us avoiding this happening. This is just part of the dynamic. So again, it's another one of these trends that keeps driving security onwards in the cloud. The fifth, and again, a lot of you, especially this audience, will appreciate this, is cloud is a software-defined infrastructure. Now, again, you can run on-premise environments in a software-defined way, but cloud by default is a software-defined environment where you declaratively specify your configuration, and that configuration is instantiated through an orchestration system. So it's not like you have to plug in a server, configure the OS, load the software. It's all configured according to software-defined infrastructure. Now, the reason this is important for security is with a software-defined configuration, you can analyze that configuration and determine whether it's secure. This is as you would describe as controls as code or policy as code. And you can really understand that your configuration is effectively managed. Then what you can also do is continuously assure that the reality that's deployed matches your expectation and your specification. This is important because, again, I think a lot of you will appreciate this, is many security incidents out there are not because of some advanced attack. They're because an organization failed to sustain a control they thought they had working. When you look at many breaches, they're not, again, are not an advanced attack. You can almost imagine the room where the post-mortem is happening, and you say, well, look, this attack came in, and this event happened, and then somebody in the post-mortem room goes, hang on a minute, didn't we have a control that stopped that? And then somebody says, yeah, we did, but it got turned off 2 weeks ago. There was a change, and we never re-implemented that control, or there was a break in the infrastructure. We didn't get around to fixing it. And so a lot of leading edge organizations are increasingly focused on this process of continuous control monitoring, constantly validating 24/7, every second of the day, that your controls that you expect to have are actually working. Again, in a cloud environment where it's innately software defined, that's a lot easier to do. The sixth one is increasing deployment velocity. So again, I think you as an audience will appreciate this more than many audiences, is the fact that what we increasingly need to do for agility and many other reasons is to push software faster and faster. Now in a cloud environment, because of our scale and because of what we do, we're continuously increasing deployment velocity in safe ways, pushing new features continuously. Now the great thing about this is our philosophy of increased deployment velocity can't help but kind of bleed into how we offer products. So when you use a cloud build or a cloud execution environment product, you're naturally more inclined to get that continuous velocity. And the reason continuous velocity is important is one of the limitations of security is not being able to get security updates or new security features as fast as you can into the production environment. If you've got an environment of increased deployment velocity, you're more likely to push security updates into the environment. And again, that contributes towards security. Now this one, simplicity, is the more controversial one, because anybody that's ever sat down at any of the hyperscale cloud configuration consoles, you don't immediately think, wow, this is all really simple and intuitive. The reality is, though, for any of you that have ever worked in a more traditional enterprise environment, the thing is, an enterprise, particularly kind of medium to large enterprises, very few people are exposed to the full complexity of their IT. You have storage engineers, database engineers, network engineers, software engineers, DevOps people, operators, security engineers of all flavors. And there's very few people that see the complexity. But when you sit down at a cloud configuration environment, your developers or the DevOps or the SREs are exposed to all of that complexity. Now they see that complexity, and it happens to be less than is in a traditional environment. But the great thing is they respond to that by complaining to us that things are too complex, which is great, because this fuels this kind of notion that cloud is an abstraction generating machine. And so we then respond by making things simpler, making things more automated, more self-defined. Classic example of this is Kubernetes. So anybody that's used Kubernetes, the distributed workload cluster scheduling system and runtime system, that's quite a complex environment. It's way, way simpler, though, than the traditional on-premise environment. So if, a decade or so ago, if you wanted to implement a distributed cluster job scheduling system for distributed consistent workloads, and you tried to do that with an arrangement of software from IBM, Oracle, Sybase, different flavors of Unix, different message brokers, a whole array of technology, it was an effort to keep the whole thing working, never mind kind of efficiently managed. And so when you turn up at Kubernetes, that's simpler than that environment, but it's still quite complex. So as a result of the people saying it's complex, we created this thing called Google Kubernetes Autopilot. And then we've created even further abstractions. And again, the great thing about funneling everything into cloud is people see the complexity, and we're driven to make things more simpler, more automated, and more autonomic and self-healing and self-defining. And then finally, the eighth one is around sovereignty. And what I mean, again, by this is, so if you think over the past 2 decades, maybe a little bit more, many enterprises, small and large, but especially large organizations, have consolidated all of their in-country data centers into large regional data centers, or in some cases, a small number of global data centers. Now around the world, not just here in the EU, but all around the world, countries are imposing data localization, data residency requirements, which means a lot of IT and data needs to be brought back into national boundaries. Now, no companies want to start implementing their own data centers again, having done this regionalization. So the hyperscale cloud providers, with this massive geographic spread of zones and regions in many countries, and especially now with the controls that can enforce data residency requirements to make sure the data never leaves that country and to make sure that support is kept in country and encryption keys are kept in country, that it's an option for organizations to meet their digital sovereignty requirements by the use of the cloud. The great additional side effect of this is it's fantastic for sustainability as well, because the widespread of cloud data centers worldwide means you get lots of different choices about your energy consumption profiles. So for example, in Google Cloud, we have this capability where you can see your carbon footprint of your workloads according to the data centers you deployed in. We have some data centers that are entirely sustainably powered, others that aren't. I mean, you can choose to deploy. So this global scale gives you sovereignty choices, and at the same time, it gives you sustainability choices as well. So I'll close there and just say, again, we invest and prioritize a lot in security, but one of the things that's going to keep driving cloud security forward is these unstoppable economic forces that are at play. And again, having worked in security for a long time, I think this is one of the best times to be in security, because we've got lots of challenges now, but while I'm still short-term pessimistic in the face of all of the threats, for the first time, I'm long-term optimistic, because these megatrends are starting to fuel a radical improvement in security and the availability of great baseline security technology that's usable in economic ways for everybody. So I think it's we're at the cusp of a radical set of improvements in security. I think that's great. So thank you.
Thanks a lot, Phil, for this very interesting and comprehensive overview. So do we have questions from the audience? We have one. Just, Wolfgang, one sec.
One large security trend could be related to quantum computing. This could be a revolution for encryption, for communication. So what's your point of view on quantum computing?
Yeah, so for the benefit of the audience, I mean, so when you look at the potential for the availability of general purpose quantum computers, we think that's going to be in the next 10, 15 years. The way I think about quantum computers, though, is, the physics has been solved. It's now just an engineering problem. One of the interesting things is there's plenty of engineers in this audience. We all know as engineers, we often surprise everybody by how quickly we can take things from physics to mass market. So it could be faster. The reason quantum computing is a concern to security is that a general purpose quantum computer of sufficient scale will be able to break most of the underlying encryption that most of commerce and the internet runs on, particularly RSA and elliptic curve cryptography. There are new post-quantum cryptographic standards. The algorithms have been selected by the US National Institute of Standards and Technology. The standardization of the algorithms happens next year. We're already piloting all of the post-quantum crypto algorithms inside cloud. We've also deployed it in field trials into the Chrome browser as well, because the new algorithms have a bit of performance impact. But we're getting ready, and I'd encourage everybody to start, especially in large enterprises, starting to think about your crypto upgrades. But where, again, another example of a megatrend is, we're going to make this a post-quantum cloud. So if you want to not go through the hassle of implementing post-quantum crypto, just tap in, and I think Amazon are doing the same. Not sure about Microsoft. Tap into the quantum upgrades that we do in the cloud.
And I have a quick related question. Key management is a big thing. So bring your own key might be, for instance, a very nice way to manage cloud-related security.
It's a really good question, because in the sovereignty point, one of the things we do, and I think all the cloud providers will end up doing this. I think we were the first. We have a solution called external key management, where customers in their own host security modules can manage the encryption keys. So even if you authorize us to do support on your data, we still can't do it without coming to you to to get the cryptographic key to do that. And so, this is a tremendous way of enforcing national sovereignty. And the other thing we have as well, this is something we partner with T-Systems on here in Germany, a thing called Trusted Partner Cloud, where we carve off some zones and regions of Google Cloud. It's then managed by T-Systems, and we separate all of the cryptographic routes away. So even if we were somehow compelled to go get data, we literally couldn't, and the law enforcement request would have to come to T-Systems. And again, sovereignty and cryptography is the way we're going to be able to keep providing these controls. It's a really good question. Yeah.
Thank you.
Thanks a lot. We have time for one more question.
Thanks, Christoph Peilo from Bosch. So I liked your talk very much, but it was geared more towards traditional IT, in my understanding. So since we are a big data and AI summit, I would like to learn your take upon security aspects of AI. So, I'm interested mostly in two aspects. So AI can fail prey to sophisticated attacks as well, and AI can be used as a way to mitigate attacks for detection also. What's the Google take on security issues for AI and for AI products?
Yeah. So we spend a lot of time and energy investing not just in the security of AI, but the approaches to explainable AI, reducing biases in training data that could bias models. And the way we think about this is it's an end-to-end data governance problem. So you've got to manage your training data sets. You've got to manage and monitor the output of models to make sure that discontinuous inputs don't cause discontinuous outputs. And then we spend a lot of time looking at how we drive explainable AI so that the models themselves can have some explainability properties. But there's a number of things, so it's important to protect the apparatus that executes the trained model. It's important to protect the training data. It's important to provide protection around how the model may actuate actual real-world consequences. And so it's not just about the model, it's about the whole ecosystem in which the model is trained and the model is used. But I think it's something we're very, very focused on, and we partner with a lot of customers around making sure that, if you like, AI ethics principles are applied to AI to unbiased data, unbiased outcomes, protect the security of the inputs and outputs, and make sure things are explainable. And I think that's ultimately what many of our customers, and in fact many regulators and governments, are looking to us to keep driving. But it's definitely something to pay a lot of attention to as we get even more sophisticated with some of our machine learning tools.
Thanks a lot, Phil, for this very, very interesting insights and considerations. So I think if you have still time to reach out to him afterwards, and thanks a lot.
Okay, thank you.